In this video, let me explain the roles of static members in class. Static members is a very special cases, different from those member variables ID, name, or balance. To explain that concept, let me extend the bank account the definition a little bit. First, I'm going to create the many bank account object like B1 and B2 and the like. And then on those variables, B1, B2, B3, I want to do some operations on them, and then I want to see the result of that. So I'm going to print those ID names and balance of each bank account the balance. So let me put those one as a function call. So let me define function prototype, void function print where the bank account parameter is provided. So let's define definition of a print function. So whatever bank account the variables provided, so I will print the ID, name, and balance of that. So put those one down here. So before I print, so let me do some divider, begin and end. So if I create the B1, I can simply call print B1 to print the contents of that, print B2, print B3, something like that. So let's try to run to verify the code. The B1, so here the parameter name is a B, so I need to change accordingly. Then I have first the B1, B2, B3, all of those are simply initial default values are there. So far so good. So what I want to do here is that on B1, I want to do some other operation called the deposit. I want to make a deposit of $100, and then I want to print the balance according to the deposit. Also, I want to do some withdraw operation. I withdraw $50, then expected balance should be 50 and the like. So to add the deposit and withdraw function, we need to change bank account interface accordingly. So here in bank account.h, I now give a void function called the deposit, and then some amount should be provided. Also similarly, withdraw function, some amount is provided, then a withdrawal will be made. So here, let me give implementation of those deposit and withdraw. So let's implement the deposit function. So void bank account colon deposit. So double amount is provided as a amount of deposit. Then deposit means balance should be incremented by the amount. So that's the deposit. And then withdraw function is a very similar. So withdraw function is given the amount is subtracted from balance. That's a withdraw function. So here in main, so in B1 we do some deposit and withdraw, and let's just see if it works. Compile. Deposit has some typo. Some part I use a deposit with E, some part not E. So dot H included with E. So I need to correct .h, the deposit, like this one. Correct it. Program works. So the B1 balance is now 50. So we can check with B2 as well. So in B2, suppose I do deposit of $500 and then no withdrawal. And then B3, if I withdraw $500 without making deposit, then those values should appear accordingly. So if I run that, it's a 50, or the balance of 500, the balance is negative 500. So those one works. So now let me explain static members. The static members are very special one, meaning that when you define a variable of the type, the static members do not appear internally for that. So far, what I explained is that when you declare variable of a bank account type like a B1, so B1 variable is created. Within the B1, so I have those members, ID, name, and balance. As I create the B2, another variable named B2 is created. Within B2, I have three members, ID, name, and balance, and the like. But if I define a member as a static, those static members never appear in any of those bank account variable, but that member will appear outside any bank account variable, but in very special area of a computer memory called the heap area. So what we need to remember now is the static members are, in terms of structure, not part of any variable. That is something you need to remember. Then based on that, we do something interesting things. So here, how do you define static member is as follows. In interface, in private member, you can define static member using keyword static, and then say integer variable where I want to know how many bank account variables have been created. So n accounts, something like this. So here, as I declare a member variable named n accounts will never appear in B1 or B2 or B3, but it will be created somewhere in computer memory as a variable n account is integer. So the n account variable is created somewhere in very special computer memory called the heap area, and only one variable n account is created. So here variable name is n account, but this one is just created once, so you will have only one single variable n accounts, unlike ID, name, and balance. In ID, name, and balance, as you create one bank account variable, another, and another, for each bank account variable, ID, name, balances are created. But n accounts are static, so that you don't have that many, but just one for the entire program. No matter how many bank account variables you create, you will have just one single variable n accounts. So using this feature, we can accomplish some interesting things, such as how many bank account variables have been created so far. You can trace that one. To have a static member variable, we need to do another one for static member. So in .h, we define the static member like this. In .cpp, we need to define static member variables again. So outside all of those member functions, so somewhere here, you need to define static member variable. So static member variables int type, the n accounts is the name of the member variable, and then you can give initial value. It's optional, but here this variable is a member of a bank account, so you need to give this special syntax. So class name colon static member variable, and then initial value should be given. Those declarations should be given in .cpp implementation as well, in addition to in .h interface definition. Then this n accounts variable is created only once for the entire program, initialized to 0. Then using this one, you can assign ID automatically as a program is executed. So here ID is given from an account static variable. Initially it will be 0, but once it's assigned, let's increment an accounts variable. Then what it means is that since this is a constructor function, so what it means is when a variable of a bank account is created, this construct is called, then ID is assigned from current value of an account, and then an account is incremented. So the ID of each bank account is automatically assigned by the number of bank accounts created so far. So that is something we achieve. So here in this terminal, let's compile the code and let's run the program. Then the very first one, ID 0, is assigned, the second one, ID 1, and then ID 2 is automatically assigned. So here in main program, as you can see, we have created 3 variables. Then ID 0, 1, 2 is automatically assigned. So here let's just do one more time. So bank account 4 is created. Then if we print value of that, now ID 3 is automatically assigned. So using static member, you can do something like this. So bottom line, the mechanism is a static member variable will not appear in any bank account variable, but it will be created outside all of those only once, so that as you change the value will be available for all of those bank account variables. It's shared, so that you can do something like assigning ID automatically or tracing how many variables of bank account has been created. Using static member, you can do that.